You ever stop and think about what's actually happening when you order food on an app? I mean, it pulls a map from one place, your payment goes through another, and it messages a driver. All at once. It's not magic, but it kind of feels like it, right? Well, it's all thanks to this sort of secret language that lets the entire internet talk to itself. And today, we're going to pull back the curtain on that language, service-oriented computing.
All right, so let's get right into the core problem. The thing is, we're living in this massive, open digital world. You've got countless different systems, all built by different people, probably in different programming languages, for totally different reasons. And somehow, they all have to work together. But here's the kicker. They were never, ever designed to. And that is one of the biggest challenges we face online today.
So think of it this way. Building traditional software, that's kind of like playing with Legos. Every brick is designed to snap together perfectly. It's a closed, predictable system. But the internet, well, that's not Legos. That's more like trying to build an entire city. You got all these different buildings made from different materials by different architects, and they all have to somehow connect and work together. It's messy, it's dynamic, it's unpredictable, and you just can't use the same old rulebook to make that city function. So how in the world do you bring some order to all that chaos? Well, it means you have to start thinking in a totally new way. You have to start thinking in services.
And that brings us right to the heart of it, service-oriented computing, or SOC for short. It's really a philosophy, a whole new way of looking at how we build software. The old way was to build one giant, single program that did everything. SOC says forget that. Instead, you create all these separate distributed capabilities, we call them services, that can be owned and run by totally different people anywhere in the world. And the whole point, the ultimate goal, is to get them all to play nicely with each other.
And you know, what's so cool about this is how simple the basic idea is. It really boils down to three key roles. First, you've got a provider. This is someone who creates a service, let's say a service that processes credit card payments. Then, they publish that service to a registry. Think of the registry like a digital yellow pages for services. Finally, you've got a consumer, maybe an online t-shirt shop that needs to process payments. They just look up the service in the registry, find it, and start using it. Provider, registry, consumer. That's it. It's simple, it's elegant, and it's incredibly powerful. Okay, so that's the theory. But to really see this in action, let's move away from the abstract and look at a real-world example where, honestly, the stakes could not be higher. A big, busy hospital. A hospital is just the perfect example of this kind of organized chaos, right? You've got a payroll system trying to manage insanely complex overtime rules for doctors and nurses. Then there's the scheduling system, which is balancing staff, equipment, and life-or-death surgical priorities. And don't even get me started on the billing system, which has to navigate this absolute maze of rules from insurance companies and the government.
And here is the absolute crux of the problem. None of these systems can exist on an island. Billing needs to know what scheduling is doing. Payroll needs info from both of them. But, and this is the huge but, they were all built at different times, they run on different kinds of computers, and they do not naturally speak the same language, not even close.
So this is the million-dollar question, isn't it? You can't just throw out decades of working software and start from scratch. So how do you get these completely separate but totally essential systems to actually talk to each other and cooperate? Well, the answer is you create a blueprint, a set of rules of engagement that everyone agrees to follow. This is what we call a service-oriented architecture, or SOA. It's how you take that SOC philosophy and actually make it happen in the real world. And this blueprint, it stands on 6 really important pillars that make the whole thing work. Let's break them down real quick. First up, we've got loose coupling. This just means the systems aren't, welded together. They're independent. They just agree on a high-level contract for how they're going to talk. Number 2 is implementation neutrality. This is huge. It means it literally does not matter what programming language or operating system a service is built on. As long as it speaks the right language at the interface, it's welcome to the party. Third, flexible configurability. This means services can be connected, disconnected, or even swapped out on the fly without bringing the whole system crashing down. Fourth is persistence. This is about trust. A service has to be reliable and stick around long enough to handle any problems that come up. Fifth, granularity. This means we're not dealing with constant noisy chatter. Instead, services have fewer, more meaningful conversations. Think deep talks, not a million text messages. And finally, number 6,
teams. The whole mindset changes. It's not about a central command telling everyone what to do. It's about a team of autonomous partners, all collaborating to achieve a common goal. And look, this whole way of thinking isn't just for something as complex as a hospital. It is the invisible engine behind so much of our daily digital lives, from buying a pair of socks online to the very future of how computing will work. I mean, just think about the last time you bought something online. You click that Buy Now button, and boom, it feels instant. But behind that single click, there's this incredible, complex dance happening. The sales system talks to the credit card system, which talks to the inventory system, which then talks to the shipping system. They're all separate systems, totally autonomous, but they're all cooperating perfectly to get you your stuff. But, okay, here's where things get really clever. What happens when stuff goes wrong? Let's say your Wi-Fi cuts out for just a second right after you hit buy. Oh man, did the order go through? Should you click it again? The system has absolutely no control over your internet connection, right? This is where the beauty of this approach really shines. The whole system is built to handle exactly this kind of uncertainty. It has options. It might fire off an email to you to clarify what happened, or maybe a tiny little applet it downloaded could just resync everything once you're back online. Or, and this is a common one, it could just place your order in what's called a message queue. Think of it like a digital waiting line, to make absolutely sure it gets processed when things are stable again. The big takeaway here is that failure isn't some huge catastrophe. It's just another event that the system is designed to manage. Now, if you take this idea all the way to its logical conclusion, you get to something called utility computing, and this is pretty mind-blowing. Imagine plugging into computing power the same way you plug a lamp into a wall socket for electricity. You don't own the power plant, right? You just use the electricity you need when you need it. Well, imagine doing that with computing. Services for data processing, storage, whatever you need. They could just be created and connected on demand. That is the kind of flexible, powerful future that this whole philosophy opens up. So what's the big takeaway from all this? What's the grand vision? Where is this all headed? Well, ultimately, it's all pointing toward a future that is built from the ground up on cooperation. There's a quote from Material we've been looking at that just nails it. It says, the keys to the next generation web are cooperative services, systemic trust, and an overall understanding based on semantics. So you see, the next big leap forward isn't really about faster chips or more storage. It's about building systems that can actually work together, that can trust each other, and that can truly understand what the other is saying. And that really leaves us with one last big question to think about. Our world is getting more connected and more complex every single day. There's no doubt about that. But are we building it smart? Are we actually designing our digital cities with the real blueprint for cooperation? Or are we just stacking up more and more digital Legos, hoping the whole tower doesn't come crashing down?